This is the first part of lesson 4.1. We are going to learn today how to solve systems of equations by graphing. To start with the warm-up, you are going to remember and practice how to graph equations of lines. So for number 1, in order to graph this line, we're going to solve for y. And so I'm going to add 3x to both sides, and I will get y is equal to 3x minus 2. So as we know, that means that our y-intercept is at negative 2. My slope is positive 3, so I'm going to go up 3 and over 1. And then I connect those dots and I have the graph of that line. Number 2, it's already solved for y, so it's in slope-intercept form. So since it says negative 3 halves x plus 2, that means that 2 is my slope, or sorry, my y-intercept. My slope is negative 3 halves, so that means I'm going to go down 3 over 2. And then I can go down 3 again over 2 again. I could go up 3 and backwards 2. And then that's going to make my line that is the equation, or the graph of the equation. Number 3, this one you'll notice is exponential. And I know that it's exponential because it has 2 to the x power. So this is not a line. The slope is not 2. So with this one, we know how to graph something like this. So let's start with that. Y is equal to 2 to the x. That's the same as y equals 1 times 2 to the x power. So that means that I'm going to start at 1, and then it's going to double. So then it will go to 2, and then it will go to 4, and then it will go to 8, and then it will go to 16, and then to 32, and then to 64, and so on. And so that's what this graph looks like, the y equals 2 to the x power. Now, if you didn't know that, you obviously can always make a table. All right, that's one way you could do it. Now, because it says plus 5, we've learned before that if you add 5 to a graph, what does it do to the graph? It means that every point moves up 5. So instead of being here at 1, it's going to be at 6. And this one, instead of being at 2, it's going to be at 7 because 2 plus 5. And then this one, instead of being at 4, we're going to add 5 to that, so that will be at 9. And then this one, instead of being 8, will be 13. And so what it's doing is just moving everything on that graph up. And so 16 plus 5 is 21. And so it's just going to be doing that. So it's going to be the same exact graph, it's just shifted up. So that's what that is looking like. Again, I always say that if you don't know what a graph looks like, always make a table. So if you just have no idea how to graph something, make a table. So we could do that by saying, well, if I'm going to plug in 3, then 2 to the third power is 8 plus 5 is 13. So 313, there it is. So that's how you can do that. And the last part of my graph isn't very precise because I didn't get the exact points, but that's the idea of it. Okay, number 4, again, we have an exponential equation. So let's start with that idea. If I have y equals 0.5 to the x power, that's the same as y equals 1 times 0.5 to the x power. So that's half-life. And so that means that we're going to start at 1, and then after 1 second or minute or whatever, it's going to be at half of that. And then it's going to be at half of that. So I'm just estimating, so 0.5 and 0.25 and 0.125. So it's going to flatten out like this. And so I know the behavior of my graph because I know what type of graph it is. And so if I can just get started with a few points, I know what's going to happen. Now, because of the minus 1, what does that do to my graph? It's going to take every single point and it's going to drop it down 1. Now, keep in mind your scale here. Okay, that's 1 right there. So when I say it's going to drop it down 1, it's going to drop it down those 5 boxes. So it's going to start here at 0 instead of at 1. And then it will go down 0.5, so I'll put it at negative 0.5. And then what's going to happen is instead of, on our first graph, we had 0 as the asymptote, negative 1 is going to be our asymptote. So that's where I'm aiming. So everything's moving down 1, including the asymptote. So it's just going to be going like this. Again, we know how the graph behaves because I know what type of graph it is. And so I'm just going to move the whole thing down. Whoops. Okay, so number 5 then is show whether or not the given ordered pair is the solution to each equation. So I want to know, is 1, 3 a solution to this equation? And so the way that we find that out is we take 1 and 3 as my x and y, and I'm going to plug in. So 5 times 1 plus 2 times 3, and I find out if that is equal to 12. Is that true? So 5 plus 6 is not equal to 12, so the answer is no, it's not a solution. And so the answer is no, but here is where I show why. So when you're asked to do that, make sure you show why. Number 6 is 1, 3, a solution to y equals x minus 7. So again, you're going to take the 1 and the 3 and you're going to plug it in for x and y. So y equals x minus 7. Is that true? No, that's not a solution either. Is 5, 2 a solution to 4x minus 2y? So 4 times x minus 2 times y. So that's 9 minus 4. Is that equal to 16? Nope. And so just before we go to the last one in this section, what this means is it means if I was to graph this line, y equals x minus 7, that means that the point 1, 3 is not on the line. And if I was to figure out what this was in slope-intercept form, and if I graphed it, then 5, 2 would not be on that line. Going back to number 5, if I graphed this equation, 1, 3 is not on the line. So the only numbers or order pairs that are solutions for this equation are the order pairs that are on the line. Those are all the solutions. So in an equation that has two variables, it has all of these solutions because all of these points are on the line. So all of those are solutions to that equation. So when I go to number 8, is 5, 2 a solution to y equals 2 to the x? I'm going to say is y equal to 2 to the 5th power? And obviously that's not true either. And so that means that this is not on this graph. And if you think about what that graph looks like, y equals 2 to the x, it's 1 times 2 to the x power. So I'm going to start at 1 and I'm going to double. So to 2 and then to 4 and then to 8. And if I think about it, if I go over to 5 and go up 2, that's definitely not on that graph. So that's why it's not a solution. So today we're going to be talking a lot about solutions, and we're going to be talking about systems of equations.